Hello, I'm Chris Boland, an OpenShift solution architect with Red Hat, and I'm here to talk to you today about OpenShift Lightspeed, and specifically a new feature that's in tech preview right now around bringing your own knowledge, your company's knowledge, to the OpenShift Lightspeed feature. Now, if you're using OpenShift, you're probably aware that OpenShift Lightspeed is an integrated AI assistant within the OpenShift console, meaning that you can actually now access specific, relevant expert advice using an AI chatbot built right into the console, so you don't have to change your workflow and go look for those answers somewhere else. But that AI environment is fairly generic. It is an expert in OpenShift. It is an expert in Kubernetes. But OpenShift Lightspeed, out of the box, does not know anything about your business. It doesn't know about your internal runbooks, any specific configurations or requirements that your business might have. But using the Bring Your Own Knowledge feature of OpenShift, we can fix that, because it's not just data, it's going to be your data, your runbooks, your knowledge built into that expert AI assistant within OpenShift. And so what we're going to do, and I'll show you this in just a moment, is we're going to take your documentation, turn that into Markdown files, add that to a vector database running in a container. Vector databases are used with a technique called Retrieval-Augmented Generation. And this is very important because we're not going to change the model. We're not fine-tuning the model. And that means that your data does not have to leave your network. We're going to keep this all safe and secure behind our firewall and not share our proprietary data with anyone else, but still get those tailored answers that we want within the OpenShift Lightspeed AI assistant. And it's actually a really easy process. The first one might be the hardest one. You've got to gather all of those documents. You've got to find your internal knowledge in wikis, in databases, in spreadsheets or Word docs. Gather all of those up and prepare those documents into Markdown files. Next, we're going to build the image. So we'll create a container image with a vector database that we can then load into OpenShift Lightspeed by simply changing the Lightspeed configuration, and then let the Lightspeed operator make that available to everyone who wants to ask a question. Here are the steps. It's really easy. Podman run. This is going to take our Markdown files and turn them into that vector database inside a container. We'll then tag that container and then push it into the local OpenShift container registry. Why that registry? We could push it to any registry we wanted, but I want to illustrate that these documents, our secret sauce, don't have to leave our firewall. I normally use Quay.io when I'm creating demos, but I'm going to create this demo using the internal registry to really drive home the fact that what is secret and proprietary for you can remain so. And then we change the OpenShift Lightspeed configuration. We introduce a little bit of spec change in it, restart. The operator will actually do the restart for us. And once those pods come back up, Lightspeed will now know everything that we've provided it through RAG, through that vector database. And so that's going to give us our customized knowledge inside our Lightspeed assistant, tailored and accessible to our OpenShift administrators. So we're going to do a demo now just to show you how easy this is to do. We're going to have our Markdown files. We'll create that container image with the vector database. We'll push that into the OpenShift container registry, and then we'll change our OpenShift Lightspeed config. As part of our demo, let's start out with level setting what exactly an answer might be that's good, and then one that perhaps is a little bit lacking. So this is my OpenShift console. I'm logged in as an administrator. And maybe I'm a new administrator and I don't know a lot about Kubernetes yet. So I've asked it to tell me about what is a Kubernetes deployment. And as you can see, Lightspeed gave me an excellent answer. It gives me the overview, key features around rollbacks, declarative updates, scaling, self-healing, replica sets, everything you could possibly want to know, and I didn't have to go digging for that. But that knowledge is really very generic for OpenShift, very generic for Kubernetes. It has nothing to do with my company. So let's ask it something about the Boland Widget Factory, which is the company that is using this particular cluster. So we're asking it specific knowledge that is not included in OpenShift or not included in Kubernetes. And what answer does Lightspeed give us at this point? Well, Lightspeed doesn't know anything about the Boland Widget Factory. And why is that? Because we haven't provided that knowledge to it yet. But we're going to do that in those 3 easy steps that I showed you earlier. And in fact, when we take a look at the knowledge that I've created, I've got something around config map secrets, deployment standards, metadata standards, network policy, observability, and service and routes. So these are the Markdown documents that we're actually going to add to that vector database and include at the end of these 3 steps as part of our Lightspeed AI Assistant answered knowledge base. So here's my rel box where I've moved my knowledge. And if we take a look, we can see that I've got my Bring My Own Knowledge demo directory with those Markdown files that we just talked about. And we'll look at those Markdown files a little bit later on. I also have an output directory as well, and that's where when we run our command to build the container image, that's where that container image is going to land. So let's go ahead and do that straight away. So I'm going to go ahead and run the command first, and then because we are doing this live, it takes a little bit of time to run, build the image, create that vector database. So while it is doing that, we'll come back and look at all the flags that I used to set this particular demo up. So let's run the command first, and here's that command, which you saw earlier in the slide, by the way. All right, so we're going ahead and running that command. Let's step back and see what it's actually going to do for us. So the first thing, podman run, we're passing the IT and the RM flags. We're going to run it interactively, and then we're going to remove the container image once it runs. Third device, passing in here with fuse, we're going to be modifying the file system of the container image as we're building it, so we need to pass this flag. We're passing our auth.json file because what this is going to do is take the container registry authorization that I did earlier to registry.redhat.io and make that part of the build so that if other container images need to be accessed, they'll be able to do so with my credentials during this build time only. And then we pass another couple more volume mounts. One is the source of the Markdown documents, that's the first one. And then the second one, the output directory, that is where our container image is going to end up being built and loaded. And then finally, this last bit, the registry.io, that's the image tool that we're using. You can see it's under the OpenShift Lightspeed Tech Preview, and then the RAG tool running on a RHEL 9 image. And that's the image we're going to build. Looks like we are almost done with that. So let's come back and take a look at the Markdown files that we're actually going to include inside of this vector database. So the example that I gave were the deployment standards. So in my Boland Widget Factory, and the Lightspeed couldn't find them because we had not yet done these steps to bring our own knowledge. So it said that we needed to have replicas with a minimum of 2 for high availability, that there were some particular standards around security context restraints, that we wanted to enforce some quotas and limits for our requests, and that we wanted liveness and readiness probes to exist. When we come back and after we've loaded our own knowledge into the database, when we come back and run that question again, we should see our specific knowledge, how the Boland Widget Factory wants us to handle deployments. Right, so we've written our manifest, and if we take a look now at our directory, we can see that we now have a new image, a tar file image in our bring our own output. I've got a couple more commands to run to load this in. So we've got 3 Podman commands here, and we'll go ahead and run these, and then we'll talk a little bit about what they're doing. And they actually run very quickly. So what have we done? Podman load. The container image that we use to build our container, its output, this BYOK image.tar, is a container image. And this podman load, we're using the podman load command to load that container image into our local podman repository. We're then, with the podman tag, we are tagging that image to have the OpenShift route or the OpenShift container registry with the tag of latest, as you can see, and then we are pushing that container image into the OpenShift registry. The final step then is to patch our OLS configuration. And essentially what we're doing is adding this RAG stanza, Retrieval-Augmented Generation, and when we add this stanza, we're going to add the image that we just created and push to the internal OpenShift container registry. We'll then give it an index ID and then the path to that vector database. So let's go ahead and patch the cluster. I could do this either through OC edit and then edit the configuration directly. I could do it through the OpenShift command or the OpenShift console and edit the resource that way, or I could actually do it with a patch command, and I'm going to use the patch command instead. So we're going to go ahead and issue this patch. And then what that's done is it's changed our configuration to use that RAG stanza that we just talked about. And I'm going to check on the pods in the OpenShift Lightspeed namespace. And what actually happens is the OpenShift Lightspeed operator sees a change to the config and it restarts all of those pods. And so right now, as you can see, I've got 3 pods running that have been running for 23 hours. And then I have some brand new pods, 2 out of 3 running, that have been running for the last 18 seconds. It's those pods that are going to have our new RAG database with our own knowledge about the Boland Widget Factory built in. So let's go ahead and check and see if we can now get specific information, not just generic information about Lightspeed and about OpenShift and about Kubernetes, but actual information about the Boland Widget Factory. So I'm going to ask this very same question again. I asked, can you tell me about deployment policies for the Boland Widget Factory? And OpenShift Lightspeed said, I don't know what that is, which is really a fair response. Now, however, asking exactly the same question after having loaded in our custom knowledge. And remember, we did all of this inside our firewall. We didn't have to send this out for model tuning or retraining. We were able to do this using RAG and keeping our secret sauce secret. We'll ask that same question. And now we get a different answer. OpenShift Lightspeed now knows about the Boland Widget Factory and our strict deployment policies. Remember those replicas that we talked about? Replicas of 2. Knows about our security context constraints. It knows about the requests and limits that we must set and our requirements around liveness and readiness probes and metadata standards. So I hope you've seen how you can take a really great feature, OpenShift Lightspeed, which really helps either experienced admins work very quickly and removes friction from their job, or takes less experienced admins and helps them level up, takes those roles and then adds in specific knowledge so that people operating the OpenShift clusters can get knowledge about their companies and not just knowledge about generalized Kubernetes or OpenShift. Now, I've said OpenShift administrators a couple different times here, and that should be a clue. This console feature is generally only available to the OpenShift administrator. However, wouldn't it be great if developers could actually get the same access to be able to know what are the standards that they need to follow? Do they need liveness and readiness probes? How many replicas for them as they're building their applications and their deployments into our Kubernetes cluster, into OpenShift? How many replica sets do they need to set? Could we, in fact, take this exact same information and manifest that out to the developers so that they can develop the applications according to the standards that we're going to hold them to? We will save that for a different video. Thanks a lot for watching. I hope you had a good time.